So we've talked about doing a GCF, where we're taking out the greatest common factor between multiple terms, bringing it out to the front. That way we can have two different things multiplied together to give us 0. So that way we can isolate, take each one equal to 0 so we can solve the equation, right? There's going to be equations that we're going to get where there is no GCF. There is no way of taking out a GCF from all the terms to get two things multiplied together to give us 0. That way we can set each one equal to 0. In general, the equation is a quadratic equation, and we talked about this before. The form of a quadratic equation. Now, this is the general form of a quadratic equation. There's two different types of factoring that we're going to learn for this. One of them is where a is equal to 1, and the other one is where a doesn't equal to 1. It's going to be any other integer other than 1. Okay. Now, the criteria for an equation to be quadratic equation, quadratic function, is if a does not equal to 0. So whenever you see something like this, where a does not equal 0, then you have a quadratic function. Now b could be equal to 0, it's still a quadratic function. C could be equal to 0, it would still be a quadratic function. And both b and c could be equal to 0. They would disappear, and you would still have a quadratic function, quadratic equation, where ax squared equals 0 or f of x equals ax squared. That's still a quadratic function if you only have this. So quadratic function, criteria for a quadratic function is x squared. You could have an x term or you could not have an x term, irrelevant. You need the x squared term in there, okay? What we're going to talk about is how to solve these quadratic equations using simple trinomial. Okay. For example, we're going to have equations like, so we're going to have x squared plus 5x plus 6 is equal to 0. And we're going to learn how to solve these types of equations. Over here, this equation is in this form. The a just happens to be 1. And whenever you have something like this where the a is 1, that's a simple trinomial, and we're going to learn how to factor simple trinomials right now. And the method is quite simple. All you do is look for two numbers that multiply to give you 6 and add to give you 5. And you break it up into two different pieces, and you take the square root of this thing and put it up front. Okay. We had something like this. There is no GCF that you can take out to have two things multiplied together, right? So we need to learn a new technique where we can break this thing out, break it up into two things multiplied together or multiple things multiplied together. Now again, if they gave you something like this, they would just say factor this. But we're going to skip that part and we're just going to go straight to solve it, because it includes the factoring part. So all they would do, if it was given like this with no equal sign, they would just say factor. If they said equal to 0, then what you're doing is you're solving this equation. The way you tackle these types of problems is you're looking, that basically it's a thought process, and you have to know your multiplication table for this. Super important. What you're doing is you're looking for two numbers that multiply to give you this and add to give you this. And I'm just talking about the coefficients here, the coefficient here and the constant here, right? So what you're doing is, initially you can make up a table, but later on it's just going to become routine. It's just, the more of this you do, and you end up doing, most people in high school math, this is, I think, introduced in grade 10 in where I am anyway. Well, it is introduced in grade 10 where I am. And by the time you finish grade 10, grade 10, you're going to end up doing hundreds of these. By the time you finish high school mathematics, if you take all the way to grade 12, you're going to do so many of these, it's just going to become routine. And it's super important to know your multiplication table, because you always start off with the multiplication, because there are less numbers that multiply to give you 6, less integers that multiply to give you 6 than there are ones that add to give you 5. Okay. What you're looking for is two numbers that multiply to give you 6 and add to give you 5. So what you can do is create a table, and what you do is you say you're looking to multiply to give you 6, and the sign in front of the number always goes with the number. So it's a positive 6 you're looking for, and they add to give you positive 5. Right? Now, it should be fairly straightforward what the two numbers are. It's 2 and 6. 2 and 3. 2 times 3 gives you 6. 2 plus 3 gives you 5. But let's start off with some of the other possibilities first, right? So what are two numbers that multiply to give you 6? Two integers that multiply to give you 6? Because most of the problems you get, they're going to be dealing with integers. So two integers that multiply to give you 6 are going to be 1 times 6 is going to give you 6, right? But 1 plus 6 is 7. It doesn't give us 5, so that's not the number we're looking for. Another two number that multiply to give you 6 is negative 1 times negative 6, right? Negative 1 times negative 6, that's going to give you 6. But negative 1 plus negative 6, that's going to give you negative 7. And that's not what we're looking for. So basically what you end up doing in this column is listing all the possibilities until you find the combination you're looking for. You start listing all the possibilities, the numbers that multiply to give you 6, and then you look over here to see if they add to give you 5. The other two other numbers that can multiply to give you 6 is negative 2 times negative 3, and that gives you 6. But negative 2 plus negative 3 gives you negative 5, and that's not what we're looking for either, right? We're looking for positive 5. So the two numbers that multiply to give you 6 that add to give you 5 are 2 and 3. So 2 times 3 gives you 6, and 2 plus 3 gives you 5. Now the way you factor this thing is, you want to break this up into two things multiplied together to give you 0. So what you do is you go right? For x squared, you have an x squared here term and an x term here. And all you do, you take the square root of this. Square root of x squared is an x, because you're going to break this up into two even segments, right? So over here you got x and x. And you take your numbers, the two numbers that you found, to give you this result, 6 and 5, and they're both positive, so you're going to go plus 2, plus 3, okay? And this is this guy factor. Now if you want to solve for it, all you do, you take each one of these things, set them equal to 0. So this becomes x plus 2 is equal to 0, and x plus 3 is equal to 0. And you solve for these. You bring the x over here, it just becomes x is equal to negative 2, right? Let's write this down here. X is equal to negative 2. And over here, you bring the 3 over, it means x is equal to negative 3. And these are your solutions to this question. Okay, so you solve this equation. And again, you couldn't solve this using the simple rules that we learn of how to move around an equation, because you can't. There's no way of combining, adding x squared and x. You can't do it. You have to break them up into two things multiplied together. Let's do a couple more complicated ones.